So there's one question about how to return multiple output in our function. So I wrote one example. Okay, here, return more than one result. So here's a function, actually just take one input size of n, and this really didn't do anything except just multiple return. So I give x, which is 1 to n, y, I just call it the color red, blue, and orange, and then I just return a list of x and y. So now outside of that, I say, this is the example of a multi-return 10, but multi-return 10z, now if you look at the z, it's basically a list of two things. The first one is an integer vector. The second one is a character vector. So what this does is so for a list, if you want to take the first element in that list, is actually double bracket. And then I just assign the first element to x, assign the second element to y. When we do that, x actually is an integer, y is a character vector. So that you can see on the side, or if I type the x, right, x is 1 to 10, y is just red, blue, and orange. So this is basically a very simple example to show you can return more than one result from a function. So, and in fact, you don't even have to put any input if the function always does just one thing. So, for example, in the top, this is the random walk example I just wrote. I guess I don't have to put the number of steps. I can put the number of steps as a global variable, in fact. I can put that as a global variable, say 100, and then I have no input to this function. And then inside the function, it's going to look for number of steps. But because I have a global function, it's going to take 100. So this is basically, this function basically is a random walk, just like for every step, you just add a Gaussian random number to the previous step. It's basically walking randomly in the place. Yeah. And also add a few the ggplot for comparison. So this is the basic plot, and that's the ggplot. I mean, the ggplot does look more presentable, even though it's really the same thing. Yeah, so. The top is the line plot. The bottom is what the ggplot can give you. So, I guess this looks more sophisticated than the top one. So, yeah. Okay, so actually I think I already updated on the GitHub. So, okay, so in the afternoon, let's conclude the workshop with a real example. In fact, many people still care about the 2020 election result. That's the unit 4. I do this mainly to show some simple statistics, t-test linear regression. That's actually the two most important thing we actually need to understand. Or at least for many of you, probably just refresh. Some of you actually are a professor. So, okay, so the unit 4 is a simple statistic with the election result of the R Markdown file. Well, for this one, we actually use the tidyverse, and you will notice there's no input file on the GitHub because most of the data are just put directly from the website. So this is the US election result from that site. It's actually a GitHub site. Someone posted it there. That said, I didn't verify whether that is the correct result or not. I just found that someone posted a result, I just used it. So, well, As the disclaimer, I don't know whether this is the correct result or not, but that's some data we can use. So, okay, so we get the 2020 election result, and we put that into the data frame in R. And if you look at this result, it has this FIPS number there. And let's look like a number of users in many data set. And Augusta County, Alabama. Number of votes, GOP 19,838. Number of votes, Democrat 7,503. Total votes, hopefully. Wait a minute. Total votes is actually more than that. It looks like that. Well, some people, I guess, didn't vote either. Yeah, total votes seem to be more than that. And the difference is probably the difference between GOP and the Democrat. Yes, that's the difference between GOP and Democrat. And then we can calculate the percentage of GOP vote, percentage of Democratic vote, and percentage difference. And those are actually additional results. Okay, so we got, anyone have trouble with this? And anyone need help? If you need help, please raise your hand. Okay. Okay, and then we can, how many votes are there? Let's find out total votes. Apparently, how many votes is that? 150 million? Is that 158 million? Is that 150? Yes, 158 million. Now that's really a lot. Almost half of the US population voted, it looks like. So, yeah, that's really a lot. Yeah. So basically, this is, we put this result, select the total vote for each county, and then just add everything up. And that's for the tidyverse. We can also use the basic R. In that case, we just use the $sign, take the number of total votes, and then put into the sum function. This is a chain of the function, and then the 158 million. So, and then we can also look for the votes for GOP, votes for DEM, and then sum that up. So, so select it for column, and sum is just operation. Apparently 81 million for DEM, 74 million for GOP. 7 million difference look like. So, okay. And we can also select the state. That is, let's say we select California. Have a look at this. In this case, if we want to select California, that's a filter operation. That means we have to filter by rows. So we are going to pick the state name with just California, and then look at the percentage difference by that. Just reorder that. Let's see. Okay, so yeah, we reorder that by percentage of difference. I forgot which one is Democrat, which how did that calculate? But it does look like it's GOP minus Democrat, isn't it? Yeah, it doesn't look like it's GOP minus Democrat. So it's heavily Democrat, that's a negative sign. Yeah. So minus 7.2, that means heavily Democratic. So, okay. Let me close other. Okay, so we rename the column 8 as percentage for GOP. But what is column 8? 1, 2, 3, 4, 5, 6, 7, 8. Oh, percentage of it is percentage for GOP. So that seems to be quite redundant. But this is and then let's see. And then we just plot the percentage of GOP by each county. So, and we also did this as a histogram. So this is like quite interesting. I mean, California usually voted for Democrat, but if you look at the county level, 0.4, 0.5, there's a lot of county are heavily Republican. So it looks like a bimodal distribution, by the way. There's a peak here. There's also a peak here. It looks like California actually have a, well, I guess, I mean, how you interpret it. But then there's also 0.5. There's also another one. So, and this is California. It's almost like just the mirror of the entire country. You have the bimodal distribution here. So the tidyverse is very convenient to summarize the result. So the election result right now is by county. What if we want to look at by each state? So tidyverse can do this much easily than basic R. So tidyverse, if you're interested in data analysis, you should invest it in tidyverse, because it can really simplify some operation, make your life much easier. Sure. Okay, so in this case, what I'm doing here is basically I'm going to pipe this. We select the state name and vote GOP, vote Democrat, total votes. And then what I'm going to do, I group by the state name. Basically, every state now I'm going to group them by. If you actually, for people from computer science, if you take a database, that's basically the same concept. It's SQL language, SQL operation. It's grouped by state name. And what we then do is we summarize. If everything is numerical, we just sum them up, summarize. After group by, we summarize them by adding up all those numbers. If it's not a number, we do not operate as, right? Obviously, there's a state name there, so the name is cannot be summed up. So if, we run that. That will give us the state DF, state data frame. So there's actually 51 states because there's also District of Columbia there. So now we have the total votes, total vote of GOP, total vote, votes for DEM, total votes. Those, yeah, because there are people who don't vote for either, so the total votes is actually greater than the sum of GOP and Democrat. So. And we can recalculate the percentage of vote for GOP, basically by dividing that by the total votes. And now we can do a histogram by state. So this is actually quite interesting. I'm actually quite shocked when I first look at this. So we plot by state and do a histogram for the percentage of voting for GOP. So 0.4, 0.6, that's 0.5. So, well, there are some state is look like almost like 70%. But there's one state is almost like a 95% something. I was when I first looked at it, I was quite shocked to see that. So, but majority of them actually around 0.5%. But which one has this nearly not 100%, 95%, I guess. Democratic vote. And the way to find, if you want to find this one, we can use the future, right? So future percentage is less than that, then we will see that state. That actually is District of Columbia. So let's see, we have votes for GOP 18.5 thousand, votes for Democrat 317,000. Well, that is really a lot. So about 94.7 voted for Democrat, 5.4 voted for GOP. So District of Columbia is really completely 95 with almost 95% voted for Democrats. That's a very interesting voting district, voting area. So, and the average, how do we find out the average? We can use the mean command. By state, the mean votes for GOP is 49.1 something. We can also look at the so-called quantile. The quantile, let's see, median basically 50%, 49.05. That's the median. The highest percentage is 69.9 voted for GOP. There's one state. The lowest that's DC, right? So 75% quantile is 58.9. 25% quantile is 40.1. Yeah. So and then we can actually, based on this, we can, to be honest, I'm not a political scientist, so I don't know what's the definition of deep red swing, or blue or deep blue. I just randomly pick up some number based on this histogram. I pick what? I pick 0.4. I pick 0.47, 0.53 as a cutoff. In between, that's a swing state. 0.53 to 0.5, that will be red. More than 0.5, that's a deep red. Wait, that's not right. That should be 0.3, sorry. You can't have a memory smaller than that. 0.4, no. Red, 0.6, 0.55. What number should that be? Deep red, 0.57. How about that? Yeah. So this means what? It's actually better if I align them so I know the definition. So I'm going to things between 47 and 53. I call it a swing. 53 to 57, I call it red. More than that, I call it deep red. And less than 0.7, I call it the blue. And less than 0.4, I call it deep blue. That's probably very stringent, but let's just use that as the. Anyone have a better suggestion?
I was thinking like 0.3 instead of 0.4, and then 0.7 instead of 0.57.
You think 0.3, 0.7? Okay.
Yeah.
No. There's no state more than 0.7, so there'll be 0.
Well,
the highest is 6.69, so 0.7 there'll be no state called deep red. So
okay, maybe 0.4 and 0.6.
Yeah, 0.6 maybe work. Yeah, so right? If you look at the histogram there, the highest value is 0.69. So if you choose 0.7, there will be no deep red state, which is right. So yeah. Okay, so where did I go? There. Okay, let's use 0.6. Let's see. And then now we separate the state by groups. Let's look at the state groups. Okay, so Alabama is deep red. That seems to be reasonable. Alaska is a swing. Probably not. Well, that's the criteria we use. Arizona is a swing. Oh, that seems to be correct. Arkansas deep red. California deep blue. Colorado blue. Colorado is blue. Okay. Well, that's what our criteria right now. Connecticut deep blue. Well, you can check which one is Florida swing. Maybe. Georgia is a swing. That's interesting. Hawaii deep blue. Well, this is our criteria. So may or may not make sense. Just for fun of it. So okay. Well, with this, we can also. This is just a voting result. It will be interesting if we integrate with other. Sorry. So we can take the census result. So this is one interesting aspect of analyzing this kind of result because there are so many data out there we can analyze. So here I'm taking the census result. Well, apparently 2020 census results are not there. So the result I'm taking is actually 2010 to 2019 census result. So, and that's basically the population by counties. And then we can merge the census result with the election result. So, and when I try to do that, you actually run into a problem because in Alaska, apparently the census and the voting follow different areas. They have a voting district, they have a census district. Those things doesn't match. So if you want to merge the census result with the voting result in Alaska, it can't work. It cannot work because they follow different maps. So I don't know why that's the case, but that's the case in Alaska. So if I want to match the location between the election result versus the census result, you will see in Alaska it doesn't match. They're all false, but in all other states it matches. So why that's the case, I don't know. But yeah, that's what the data is. So if we want to merge the census result with the voting result, Alaska will have to be thrown out. It cannot, basically it cannot be merged. So, all right. So let's so now we are going to merge the election result with the census result by location. And we know after this, Alaska won't be there anymore. So, and this is I call this election census DF data frame. So election census, election census DF. I run this. Do I see that on the right-hand corner? Oh, here, okay. All right, so now we have the county result, state, county, vote of GOP. Oh, yes, those are the census results, 2010, 2011, 2012, all the way to 2019. We don't really need so many. Let's just pick 2019. So I'm going to just pick the state vote, GOP votes, DM votes, total votes, and 2019, and throw away the rest of it. And then again, we're going to group by the state and sum up all the results. Then we have the state, the result with the votes and the population total population. So there. So now we have the result of Alabama, GOP votes, Democratic vote, total votes, and 2019 population. 4.9 million, is that? Yeah. But 2019 is really not a good column name, so I renamed that as a population, or maybe total population. So, yeah, so now our data frame is like this. GOP votes, DEM votes, total votes, population by each state. And there are 50 of them, but District of Columbia is there, Alaska is not. And simply because Alaska census and the votes follow different locations. Okay, so, and then we can, so we have the state population. I'm also move this back into the original data frame using the match function. That's simply, I could actually use a second one. I'm not sure why I'm doing this. I guess just to show the match function, how it works. Yeah. The match function is actually a bit confusing if you don't know how to use it. What I'm trying, so it had to be that, so this is our target, that's our source, and we're going to match everything from the target, that's the target, to the source, and then look for every row in the source column. I actually have a separate tutorial on this one, but for now, let's just use this as is. So, and then we can actually look for correlation. We can use linear regression is probably the most common used model. We can see whether state with more population voted for GOP, tend to vote for GOP. Obviously, there's no significant correlation. P-value at 0.25 something. So there's no significant correlation between the total population of the state versus the vote for GOP. Well, that's probably not surprising, right? State with large area tend to have more people. State with a small area tend to have less people. So it's probably, we can also check for the population versus the category of state, deep red, deep blue. So, and then do a regression on that. In this case, actually we do have a, well, less than 0.5. So you actually do see, if we do a categorical analysis, there is some correlation there. In fact, if you look at the plot, deep red total population here, deep blue, that must be California. Yes, Texas is one of those. I don't remember what's the population size of Texas. I guess California and New York might be somewhere there. So blue, red, something. But the next example, what I'm trying to do is, well, instead of calculating the total population, maybe population density is a better predictor. So now I'm actually taking the area of each state. So state area. That's basically each state, how many square miles, I guess. Delaware, does it have DC? Oh, it also has DC. DC has the smallest area, 68 square mile, it looks like. And it also has Puerto Rico there. So, and then we need to match this. This is the UserMatch function. Then we need to make sure each state had the area are matched, because the two data are now not in the same order, right? So or maybe they do look like alphabetical order. How about the election result? That also look like alphabet, except District Columbia is here, but the state area, no, District Columbia at the bottom. So not exactly alphabetical order. So we need to match each state to its right value of a state area. So again, use a match function. So state area is the value we want to find out, but which row we use a match to find out. And this is our design. That's what we want to locate it. That's the result. So we're using the result key value state name. Look for the input state area input name. And where are we looking for that? After we identify that row, we pick the area of the column. So once you get familiar with the match function, it actually seems to be quite intuitive. But right now, let's just use that as is. And then after do that, after I run these lines, if we go back to the state, is state df, is that this one? Okay, so let's see, do we have a area? Yes, now we have pop area there. And then we divide the population by area, then we have population density. So yeah, so we divided the population by area, then we have population density. And now we can do a linear regression to see whether the GOP votes and correlates with population density. And these turned out to be a very significant correlation. quite interesting. So there we have a p-value less than 1 out of 100,000 significant correlation of the votes for GOP versus the population density, which is actually, if you think about it, really not surprising. Not counterintuitive, it's very intuitively that's the case. And we can also plot the population density and the votes of population and see whether that is indeed the case. Now, once we plot this one out, you will realize District Columbia is really an outlier. So, yeah, that's the. So, actually, our TA figured out the better way to do the correlation, I guess. Yeah. So we might want to. So even though there's significant, it looks like the District Columbia is not a normal. It's not. I publish it. It's not typical in this data. It looks like it's an outlier. So we have to remove this outlier. So then we just filter this one out. Filter the District Columbia out and call it the state data frame number 3. And now we redo the linear regression, see how it looks like. I'll redo the plot. Actually, plus linear regression. So after we remove the District Columbia, we still got a very highly significant correlation. So, but I didn't summarize the. Did I summarize? No, I did not. Summarize linear regression model. What do I call it? State df3. Votes for percentage of vote of GOP versus what? df3 population density. Okay, yeah. So let's see. Wow, that's still very small. 1 out of 10,000 is still a very small p-value, but it does show that District Columbia obscure this by 10-fold, right? With the District Columbia, we have what, 1 out of 100,000? Yeah, that's actually so the District Columbia does have some effect on this linear regression, but even after we remove it, we still see this very significant correlation. So yeah, that's actually not really surprising, isn't it? So with New York City, LA, almost every large city I can think of seem to follow this trend. So. Okay, so there's obviously many different ways to visualize this. So we can one way I'm trying is the box plot. Look at the population density distribution. Wow, this is become much more visually striking, isn't it? So we have the deep red with a very low population density, but deep blue now the median there is almost like a 10-fold higher, is it? So yeah, so it seems to be quite obviously deep blue has a much larger population density than the deep red. And we actually can verify this using the so-called t-test, student test. So the t-test basically going to compare the mean value between two samples. This is also two-sample t-test. So we can take the deep red population density, which we call it deep red using our own criteria. And we can also take the deep blue population density and then do a t-test. And the t-test, the null hypothesis with the two sample mean are the same. And in this case, our alternative hypothesis is what? Deep blue population density are greater than deep red population density. So the way p-value means if the p-value is very small, in this case, 0.000, that is very small, right? So 1 out of 1,000 almost like. So that means we reject the null hypothesis, which the null hypothesis means that two lists of numbers have the same mean, and the alternative is what? Deep blue population density is greater than deep red population density. Because the p-value is so small, we reject the null hypothesis. So the alternative hypothesis is what? Deep blue population density is indeed greater than the deep red population density. So this is a very simple example. Hopefully you found it a bit entertaining, I guess. Okay, so I look like the TA also has an additional plotting. Let me try that, see how it looks like. Let's see. ggplot, state the DF, state name, percentage GOP, bar identity, scene. Oh, yes. In fact, you can use scene to do a lot of a very fancy plot. Let's see. Very good. And this is basically state by state bar plot. Oh, this does look nice. Yeah. So, very good. So let's try the next one. Although there's actually books on the books how to do visualization in R. If you go back to our training website, let me see. I think I listed some of the material there. So maybe not. Let's try this. I thought R data visualization is part of this. No. Oh yeah, here is Fundamentals of Data Visualization by Klaus Welk. That's a very good. It also had a GitHub repository. So there. That's you can see there's a lot of a very fancy plot there. Oh, I think that doesn't show up here. There. Oh no, that's not our plot. Sorry. No, I don't know where he put his plot. This is a very, very good book for data visualization. So, and including how to look at the choosing visualization, a color basic coordination. It's a geospatial. This basically there are books and books on data visualization in R. So let's try a different one. So reorder by state name. I guess that will make sure the state at alphabetical order. So. Oh, this is reorder by the percentage. Oh, that's interesting. Yeah, this, wow, it does look like District Columbia is an outlier, isn't it? So, yeah. Very good, thank you, Trevor. Yeah. But this, there's a lot of data visualization in R you can explore, trying to. It's actually arguable what is the best visualization, because visualization is kind of a subjective, right? It depends on your own perception, background, context. So I don't think there is a answer to what is a perfect visualization for a data set, but you have to depend. In fact, there are people, I just recently see people analyze a GOP visualization versus PEM visualization. There's actually somehow the partisan preference on what kind of chart people use. They look at one group prefer pie chart, another group for some reason, I don't know what happened there. So apparently there's even some preference on the on different group, what's the best way to convey their messages. So it's actually quite interesting, kind of entertaining for me to read that article. So apparently people analyze a lot of advertisement promotion message and then come up with that conclusion. So, yeah. Questions? Oops, let me go back. Okay, if not, I think it's please take the anonymous survey link here. So I'm also going to put that copy link. I put that into the chat window. So that's an anonymous link. You actually shouldn't. Oh yeah, the LinkedIn group update with state bar plot. In fact, it even show what change I made. It looked like yeah. There, the green means I added there. Those are the bar plot I just added on there. So.